Banerjee, Post-Doctoral Fellow at Vainu Bappu Observatory, Indian Institute of Astrophysics. Dr. Banerjee specializes in stratospheric studies of stars, holds a PhD and MPhil in astrophysics from Christ University, and an MTech in astronomy and space engineering from Manipal University. He is a life member of IAU, ASI, and IPS. He has delivered 500 plus astronomical talks across India. He is the author of 2 books, Becoming an Astronomer, a career guide for aspiring space scientists, and Mars, a celestial showstopper. His journey is a testament to how passion and perseverance can carve a stellar path in astronomy. This is going to be an absolutely fantastic class. Today's session is about exploring astronomy in the present era, career paths, and citizen science. We'll give you a roadmap to enter and thrive in the world of space science, whether through research, technology, or public participation. This is where curiosity meets opportunity, so you will get to know a bunch of things. I will now cue in Sir, so you can take the mic, sir. We'll start with the session, and happy talking, everybody.
Hi. Hi. Good evening, everyone. And maybe good morning to the people who are joining from across the world. So let me share my screen first. And I hope I am audible and I am visible to everybody. The screen should be visible to everyone, right?
Yes.
Yeah. Okay. Thanks. Okay, so first of all, yes, thanks for this wonderful introduction and thanks for this wonderful initiative from Propagation Institute and also Asia Citizen Science Group and any other organization who might have contributed for this wonderful organization of this 1 week celebration of World Space Week. So this Space Week is celebrated across the world to commemorate, because as we know, many of you already have known that 4th October, it starts every year because 4th October 1957 was the date when space journey for humanity began. So Sputnik, the first space satellite or space object, went to space from Russia or USSR, and that to commemorate that wonderful, excellent achievement by humanity, we in nowadays celebrate this particular week, October 4th to October 10 every year as a World Space Week. As I have learned that so many discussions have been carried out in this particular theme, where living in space. So I thought that, okay, let me concentrate on not talking about something living in space or astronaut training or suppose astrophysics, because I believe that these things have been very well discussed in the past 5 days by these organizations or this particular initiative which has been taken by Propagation. So let me today concentrate on, as the team has already mentioned, about the career path. So if someone, specifically if someone from India or anyone from outside India also, if you want to become an astronomer or if you want to come to the field of astronomy and astrophysics, then how can you contribute? From what time, from what age you can start contributing? And specifically if you are an Indian and you want to take astronomy and astrophysics as your career, what you have to do, how you can progress, and where you can land. What will be your salary if you become an astronomer in future? What are the institutes and where you will get a job? So these are some of the prospects. I believe that many students, many young students, even maybe their parents, teachers, they want to know. And this is the most frequent question which I also receive when I travel for talks and delivering lectures about popular astronomy. Sir, what next after this talk? What next if I want to go to astronomy field professionally or maybe in an amateur stage? How can I contribute? And what is the future path? So I thought that, okay, let's discuss these things. What is the status of astronomy presently in present days? How astronomy is doing overall? What is the status of astronomy? And what are the career paths? And what is citizen science? How one can contribute? And how much one can contribute being a non-professional or definitely if you want to become a professional. So let me start the journey from history. Yes, as we know that if we go back very to ancient days, means before pre-recorded history, before pre-written history, astronomy might have started from very ancient days, most probably when human beings first started roaming the earth. So most probably during the first day from maybe from the first time or first days when Homo sapiens, means humanity, started roaming in this earth, they were watching the sky. They looked at the sky. They didn't understand what is the meaning of the sky. What are these objects? But humanity or human beings, Homo sapiens, they looked at the sky. One of the major reasons most probably will be, or what we believe is, the human curiosity. This is a natural instinct which no other animal possesses. So due to this natural curiosity, mostly due to this natural curiosity, we think or we believe that human beings are watching the sky for so many years, from very ancient days. Now, likewise, like we have genius people, some great people nowadays, during those days also, there were people who were intellectuals, who were bit better, who were bit thoughtful than others. So for years after years, days after days, when people were just for fun or just for curiosity purpose, they were looking at the sky, some people might have gradually understood that just for sake of curiosity purpose, looking at the sky may not be any meaning. But if we try to find out some meaningful patterns in the sky, that will be helpful for humanity's growth. And my friends, I can proudly say, the people who, all of you, why you are joining there today in this talk or in this endeavor is because I believe that all of you like astronomy, love astronomy. So I can proudly say that astronomy is a subject, knowingly or unknowingly, it is very much deeply rooted from very ancient times for the wholesale or whole-scale development of the humanity. Humanity's progress in every aspect, in every subject, in every area, highly dependent on the development of astronomical knowledge. And that started from very ancient days. So few people gradually from different civilizations, ancient civilizations, they understood that if we go on looking at the sky, and if we try to see the sky every night, then we will see some bright stars. Nowadays, we know these are stars. That time it was meaningless objects. So basically, some of these bright dots, they are brighter than the surrounding fainter dots. And if we can join these bright dots using imaginary lines, then these bright dots will give rise to some imaginary patterns. Likewise, the ancient people ultimately divided the whole night sky into different such imaginary patterns. And these patterns are what we call nowadays as constellations. So definitely we know the most famous constellation in the sky is this Orion. That's why I'm showing this picture, as if it is representing an imaginary hunter which is standing in the sky and trying to hunt something. That something is an imaginary bull. It's according to mythology. But how this making of patterns or imagining patterns in the sky helped us? It helped us to make the first map, the first calendar. It helped us in navigation. It helped us to understand how seasons are changing. Remember, I'm talking about a time when there was no clock, no modern equipments, no instrument, nothing was there. Thousands of years ago, even before the Bronze Age and maybe before the Iron and Bronze Ages. The only thing which we can look into, the only clock which helped us, the only calendar which helped us was this night sky. And obviously, if the sun is there, then the morning sky also up to a certain level. So presently, we know that the sky is divided into 88 sets constellations according to the rule made by IAU, International Astronomical Union. But how it looks like? If I see the winter sky, this is how the winter sky patterns looks like, or the constellations of the winter sky looks like. What it tells us, now we can understand if we see these patterns, this is the Orion. If I show the known figures, this is the Orion. Now, what I'm trying to say, if we see that this Orion is rising in the northern hemisphere of the Earth, then people used to say during those days, ancient days, people used to understand that winter is approaching. This is how there was an idea. They got the idea when winter is coming, when seasons are changing, what crops to be cultivated, and so that those crops will not get destroyed in a particular season or due to floods. During navigation, how will we understand in the huge sea or unknown land where we are going is correct? to understand the direction. All these reasons, the sky was the only source of helping hand. For many years, before the invention of these clocks, compasses, before the development of proper electronics, humanity had to trust on night sky for very basic things, like even for agriculture, even for navigation, even for cultivation, even for understanding how the seasons will change. And this service is still now offered by the night sky. Anytime if you get lost in some place where you cannot have your mobile phones ringing, where GPS is not working, you don't have a compass, maybe you don't have a watch, if you have the night sky above, you can actually very precisely, if you know how to know what's the night sky in a scientific way, you can very precisely locate your location, understand so many things, even your latitude and all, what is the time at that particular moment, even not having a watch. You can do these things and you can return back, or you can find the directions. So this night sky became our first calendar, our first navigating tool, and gradually human beings started understanding that not only that, if we go on studying these stars or planets or objects of the night sky, we will be able to develop instruments, such instruments which will help us to understand how to navigate in this earth in a more precise way, how to live in this earth in a more comfortable way. Some such instruments were like this. So one of the oldest astronomical instrument which we know exists is this one, this type of instruments. It is known as an astrolabe during those days, but presently also this instrument is used by navigators, and we know it as sextant. The well-known instrument sextant is basically an astronomical instrument. So what it does, it helps us to understand what is the latitude of a place. So basically by looking at the pole star, we can understand what is the latitude of a place if we have this instrument. Now, these were the instruments, some of the old instruments before modern instruments, modern technology evolved. These were some of the astronomical instruments which helped humanity for thousands of years. Another instrument is this. We know that in the morning time, if we do not have a clock, then how people used to keep track of time? By watching the sun. And the instrument which helped us in that was a sundial. Likewise, for night purpose also, we have such instruments. For understanding the map for identifying stars and constellations in the night sky, we have this particular instrument, which is known as a star map or star dial or planisphere, whatever one can call. So these were some kinds of instruments which were used during those days when humanity's progress was hindered by the lack of technology. But yes, I can go on telling about those ancient days so long, but let us come to a position where gradually the new age of understanding was coming up, specifically in European places, and gradually it was spreading very rapidly to other places. So we had to wait for a long time till 1609, when the greatest weapon to understand the night sky was invented or used properly. And that instrument definitely is the telescope. There are different types of telescopes. You can see here that nowadays we use different types of telescopes. Even we have binoculars, means handheld telescopes. So these type of telescopes anyone can use binoculars for watching the beauty of the night sky. To a certain level, you can photograph the night sky, that is beautiful. And yes, if I go to the history, this is the person, Galileo Galilei. Remember, this is not the person who invented telescope. The telescope, according to written history, was invented by another person who was not a scientist. He was from Holland in Europe, and he invented the telescope. He was a spectacle maker. He was not a scientist. His name is Hans Lippershey. Hans Lippershey in the year 1608. But during that time, nobody understood the real potential of a telescope. What can it do? So it was not known as a telescope. This instrument was in its initial days known as spyglass. What it was used for? It was used for war purpose, to see enemies approaching from a faraway point. What it does, basically, we know that a telescope actually helps us to see a very far away image in a bigger way. So it magnifies an image. Now, this person who was in Italy, Galileo, definitely a genius. The news of this invention of such a wonderful instrument spread very rapidly in European places. And he came to know that such an instrument has been discovered or invented through which I can see something farther away object as it will appear that it is nearby. So it will magnify the image. He was a genius. He knew, so whenever he learned about such an instrument, within a year, in 1609, he made his own telescope. So why is he genius? Why is he notable? He was the first person, Galileo was the first person who actually understood that if an instrument is there through which I can see farther away objects in a nearer way, in a bigger way, what are the farthest objects we can see? Definitely the night sky, the sky. So he was the first person who pointed his telescope towards the sky, and which gave birth to modern science, modern astronomy. That is why 1609 is known as the year of birth of modern science and modern astronomy. Whatever he saw in the night sky using this instrument, although that was a very small, very simple instrument during those days, but whatever he saw actually changed everything what we know about basically the universe or the sky. So from that day onwards, time has passed. Without going details to the history, I will come to the present days. Simply as I have told, and you will know.
I would like to interrupt you a bit.
Yeah.
I think your camera is not on.
Yeah. Hello. Tell me.
I think your camera is not on, sir. If you turn it on.
Camera is not on. Yeah. Shall I turn it?
Okay.
Yeah.
Yeah, that's fine.
Yeah, because since I'm talking from this observatory remote place, so I am keeping it switch off as of now.
Okay.
Yeah, because there will be buffering problem might be. Yeah. Okay. So later I can turn it on after the talk. Yeah.
Okay, sir.
Okay. So basically, what I was talking about is presently we have come a long way. Now, as I have already mentioned, and you people might be aware that using simple amateur level telescopes, what Galileo was using, or what I am showing in these pictures, using these telescopes, we can see the sky, we can enjoy different night sky objects, we can also photograph them. But for doing some scientific work, we need more powerful, more sophisticated, and bigger telescopes, bigger instruments. And those telescopes are known as professional telescopes. Where they are kept in different remote places. The first three images shows us some of the largest telescopes of the world, and the places where they are installed are known as astronomical observatories. The last image is an artistic impression of a future telescope, the 30-meter telescope, which is going to be the world's largest optical telescope system. So India is also one of the leading part in this project. Now, hopefully, I am able to convey one particular fact that we have come a long way from those days, from ancient days when we had nothing, when humanity was only looking at the sky through naked eyes, to this point where we have professional telescopes, sophisticated instrumentation, and even we know that we have telescopes at space outside our Earth's atmosphere. So we have come a long way. What we have achieved during this time are very, very huge knowledge about almost different types of astronomical objects. What India is doing during these days, definitely in the present day, India is one of the most powerful countries in astronomy research and space research. I am talking to you people from this particular place today. I stay in this place, which is known as Vainu Bappu Observatory. It is one of the most important astronomical observatories, not only in India, but whole of Asia. It is an optical observatory. We do optical studies of astronomical objects. Definitely, it is under the institute, which is Indian Institute of Astrophysics, under Government of India. where it is located. This place basically is located in a place known as a small town, not even a town, a small remote village in Tamil Nadu, which is known as Kavalur. And we astronomers, optical astronomers of India, fascinatingly, we love to call this place as the telescope town of India. If you want to read about its history, it's a huge history is there. You can read this article. You can go to this article and read about it. So basically, this is a place in the Nilgiri forests of Tamil Nadu state, deep forest, absolute remote place. There is almost no light pollution. There is almost no noise pollution, very fresh food, and definitely wildlife is there. But these are the types of places where you should place your professional telescopes, your observatories, so that you can watch the sky, night sky. We cannot make our observatories in a very in such places where light pollution is there, like cities, outskirts of cities. That is not possible. So we have to come and make our observatories in such places like this. So this is one of the picture from our country, from what we are doing, what kind of facilities we have. I will come to this when I'm talking about the carriers. I will come to these things later, again in details. However, as I was mentioning that, as I already told that this observatory where I am working now, I am an optical astronomer. Basically, what I do or what we do, we majorly study the optical wavelength of light, which is emitted or which is thrown away by different astronomical objects. Now, as we know, if there are anyone who is in maybe less than 15 or 13, 14 years old, you might not know. So this slide will describe it. As we know, or we might not know, what is light? First of all, let us give a small introduction. Okay, light is a type of energy, and this light, what we know as something known as light, is a type of energy which has a huge range, which spans from a huge range to a huge range. Why I'm telling this? Because our naked eyes, our human eyes cannot detect the whole range of light which is actually possible to detect. So if we had a Superman or He-Man eyes, Superman, the comic character Superman, the character, cartoon character Superman could see X-rays. What does it X-ray means? It means that it is a form of high energy light which our eyes cannot detect. So if we see this huge range, the whole spectrum of light, which is known as electromagnetic spectrum, in this whole range of light, there are different types of light which is possible. When we call about this thing, that ultraviolet, X-rays, gamma rays, infrared, microwave, radio, these are all types of light or types of that same electromagnetic radiation or energy. Out of this whole range, you see only this small window, this small part which consists of only 7 colors, basically. This small range of the whole light window, our eyes can detect. It has a certain wavelength, 4,000 angstrom to 7,000 angstrom, certain frequency, and it consists of so 7 colors. The Fibgeo, these 7 colors of light, this small range in this whole window, our eyes can only detect. What about what will happen in that case? If our eyes, or if we are only making telescopes which are like this, these are the domes inside which the telescopes are there. As I have told, these are also optical light or optical telescopes. So basically the light which our eyes can detect is known as visible light or optical light. So if our eyes, or if those telescopes, we only make telescopes which can only detect this much amount of light window. But light exists here also, left-hand side also. If we cannot make instruments or such type of telescopes which suppose can detect microwave or ultraviolet or gamma rays or radio waves coming from space, then it will be like we are trying to understand the night sky, but being a blind man. It's that same story that 7 blind men or 10 blind men, each of them trying to understand what and how an elephant looks like, what is the size and shape of an elephant. Everybody will know little, but nobody will have the complete knowledge. And the same thing will happen if we do not make sophisticated telescopes which can detect the other types of light which our naked eye or optical telescopes cannot detect. So my friends, why I am telling this? Let's see this image to give a comparison. You see, this is the image of our well-known sun. The second image shows you the image of sun if you take the image of sun using an optical telescope. So if an optical telescope takes the sun's image, it will come like this, the second image. Can anyone say that looking at this image, that sun is a burning ball of gas? No. Instead, it appears calm and quiet, wonderful, stagnant ball. So that means our own sun, which is the nearest star to us, it is hiding its real flavor, it is hiding its real nature in optical light. So what scientists have done, what astronomers have done, when they started taking the same image of sun using an infrared telescope, the first image, you see now we can understand sun has started revealing itself. Now it looks like fire. And same sun, if we take using an ultraviolet telescope, UV telescope, now you see how sun looks like. This is as if really it's as a burning ball of gas. But sun actually reveals its actual dangerous glory if you take sun's image using an X-ray telescope, the last image in green. So here you see it really looks like it is not a calm and quiet place. Something is going on. It's a very active place. It is a very dangerous place. See, if our own nearest star sun does this kind of hiding and seeking, plays hide and seek with us, because if we only have one eye, that is the optical eye, so our own nearest objects in space will play hide and seek like this. Think about the whole universe, which is so big, having so many types of astronomical events happening, phenomena happening, different types of celestial objects, and they are mostly most of them, they radiate light, they radiate electromagnetic radiation in different bands, radio, microwave, X-ray. All high energy events take place mostly not in optical, but in X-rays, gamma rays, higher energies. All cool events, star formation and all these things, you can very well study if you go to infrared and cooler region if you try to study the cooler bands. So that's why in a long run from 1900 onwards, gradually, it was not only that telescope discovery was or telescope invention was important, humanity ultimately had to wait for the development of technology. So now science and technology, astronomy and technology is a hand-to-hand, friends. They run hand-to-hand. Having sophisticated telescopes, knowledge about astronomy, and complemented by sophisticated instrumentation, sophisticated technology. When we use these things both together, then we get to know the universe in its full glory. That is why different types of telescopes. I am not talking about general optical designs or general types of telescopes in case of optical telescopes like reflecting, refracting. Now I am considering different types of telescopes which can not only see the visible wavelength or optical light, it can also track, it can also detect the other types of wavelengths, the other types of electromagnetic radiation coming from space. For example, in India boasts of possessing one of the most impressive, most finest, most powerful radio telescope system in the world. Where it is located in a place, Narayangaon, near Pune, in Maharashtra. So it's a system, it's known as giant meter wave radio telescope. You see this type of antennas. And there are so many antennas. There are total 30 such antennas. Each antenna has a diameter of 45 meters. From here to here, it is 45 meters. All these antennas are steerable. This can be steered single-handed, means each antenna can steer separately. And even all the antennas put together, they can be steered at a single command, as if they can make a complete virtual telescope having a diameter of 25 kilometers. So now you can understand the the power of technology, the power of science, and the power of human minds, intellectual human minds. So there are different types of telescopes. And as I am focusing on India today, yes, India has come a long way in its long journey. India has come a long way. And these are some of the examples where we are situated now. In the meter wavelength category, this radio telescope system is the most powerful in the world. So basically, what are the facilities? What are the opportunities we have? If we are having such wonderful facilities in our own country, and that is also, my friends, I would like to say, these are all increasing. Astronomy in India is rapidly increasing. So what are the future facilities or future prospects we can get? How we can contribute? And after so many years of studying about space and astronomy, why we should have to again consider astronomy? Should we go on studying astronomy again and again? What we will gain? We will gain so many things. And how you can contribute, how one can contribute. First of all, let me concentrate on contribution in astronomy by anyone in this world. If you are a human being, you can contribute. There is no need of you becoming a very hardcore professional astronomer. If you want to become that, definitely you can, and you are welcome to become that. But if you are an amateur, if you do not want to come to professional astronomy, but still you want to contribute, being a non-professional, nowadays there is opportunity to do that. And this is majorly done by some different types of projects who are collectively known as citizen science projects. What is citizen science projects? Basically, it's the concept that if any citizen of the world wants to contribute in professional astronomy, he or she can contribute. Only one thing is required. You have to have interest in astronomy. And anything else, no other eligibility is required. Because why this is possible? See, if I want to become a doctor, if I want to become a lawyer, I might like lawyer profession. But is it possible that if I do not do the formal studies in law, and I want to say that, okay, I want to fight a case, a murder case. Will I be allowed to do that? No, it is not. I might like surgery and all these things. But if I am not a doctor and if I say that I want to do surgery because I like it, will I be able to do that? Will I be allowed to do that? Permitted? No, absolutely not. But astronomy is a subject where up to a certain level, amateurs can definitely contribute. It is a very rare subject where obviously professionals are contributing, but the contribution of amateur people in the subject of astronomy from very ancient days is absolutely huge. I have listed some very famous names of scientists or astronomers whom we know, but basically they were not professional astronomers. They were basically amateurs. Definitely Galileo, Giordano Bruno, William Herschel, the person who discovered Uranus. Nicholas Copernicus, who changed our ideology that we are not belonging to a universe where we are at the center. Sun is at the center. So here I have listed some very basics in only one page, whatever is possible. World-class, world-renowned contributors in astronomy. Not only that, some of them are genius astronomers, but they were not formal astronomers. They were all amateurs. So what I want to point out is, takeaway is this: being an amateur in astronomy, one can contribute. And nowadays, it is a wonderful time, wonderful period where one can contribute in different ways. How? Let us now come to this aspect. Let me go to the aspect of citizen science concepts. What does citizen science tells us? It tells us that, see, as we being professional astronomers people, we understand that every day, due to the huge progress of technology, telescopes, instrumentation, we are getting huge amount of data every day, coming from different telescopes, different spacecrafts, different types of objects. But who will ultimately help in analyzing that amount of data? The profession astronomer is very, is a very less not less, I will say, is a very counted profession. So if you check the world population, you might find one person being an astronomer among maybe 15 to 20,000 people in the whole world. The total number of astronomers in the whole world will not be beyond 2 lakhs out of 800 crore population. So the amount of astronomer, professional astronomer, is basically very, very less in the world. And that's why this citizen science concept came, that we need the help of anyone from this world who wants to contribute. Please come forward and we will help you so that you can contribute in astronomy research. How? One example is this. What I'm talking about, I can give an example through this. So basically what it tells, see, there are so many stars in the sky which are basically variable. Means their brightness will vary. Even the one of the most prominent star, which we known as, this pole star, the North Pole star, which we think that it remains fixed at North Pole whole life. So it might be true for some particular person's life, but it's not absolutely true. And moreover, this is pole star basically. If we go on looking at pole star every day, we will see its brightness also varies. Sometimes it becomes brighter, sometimes it becomes dimmer. And as we have studied more and more number of stars, we have found that thousands of such stars exist. Maybe more than lakhs of such stars exist in our own galaxy, whose brightness varies. And these are collectively known as variable stars. There are so many reasons for why we get such type of variable stars. Maybe there are two stars, binary or trinary stars, two stars revolving around themselves, as a result causing brightness variations. There can be explosions like supernova causing brightness variations. There can be some internal reasons. So there are so many types of stars which are basically variable stars. And it is very important to study these variable stars. Why? Because systematic study of variable stars and their periods of variability determines how stars behave, the evolution of stars, the stellar life cycle, and how nature behaves in a broader way. So by studying variable stars, some of the greatest discoveries which have taken place is this. This is also a small list. You see, there are some type of variable stars which are known as Cepheid variables. So by studying these type of variables, we first got the understanding that our universe is expanding, and we were able to measure the age of the universe. There are some other types of variable stars which are known as Mira variables. Now, these type of variable stars actually give us proper understanding how our sun will evolve, or sun-like stars, low-mass stars like sun, how they will evolve. We can understand by studying these Mira variable stars. Even by studying some other types of variability from special exploding stars like supernova. A particular type of supernova were studied during late 1990s, and we got the surprising realization that our universe is not only expanding, but its expansion is accelerating. So the universe is expanding in an accelerating rate. How we knew about it, how we came to know about it, by studying a particular type of supernova, basically which are variable stars. So now we have so many variable stars in the whole universe. We have huge data. Who will analyze this? Who will help in understanding the time periods of variability of different known and recently discovered variable stars? For this, we need the help of amateurs. We need the help of anyone who is interested. And my friends, for this purpose, this particular organization is set up. It is known as American Association for Variable Star Observers, American Association of Variable Star Observers. If you go to this organization website, you can see here, you can become a member, and you can also help in observing variable stars, measure their time period, and submit your observations in this APSO. This is a very old, this organization exists from 1911, a very old organization based in America, which is actually helping stellar astronomers in analyzing variable star behavior. And who all are taking the data of variable stars? Mainly amateur astronomers all over the world. And this AFSO is having the largest database of variable stars in its database. And being an Indian, I am proud to announce that one of the greatest contributor in the history of AFSO and in the history of variable star research was this person from undivided West Bengal area. It was that time Bangladesh. His name was Radha Gobindo Chandra, who has contributed. He was a peon. Basically, he was a peon. He was an amateur astronomer. See, he was a peon, but in his lifetime, he has done such miraculous works in variable star studies that he has received accolades, and he has received accolades from almost every part of the world except our own country, India. So that is unfortunate. But you can see this. He has submitted more than 37,000 proper, correct observations to this Harvard College Observatory, and these observation reports are presently kept at AFSO office. Even Harvard Observatory in 1926 presented one 6-inch telescope to this person, because he was a peon. His salary was not even that much that he can eat 2 times meal properly a day. But for 60 years, he has continuously observed variable stars and meticulously reported more than 37,000 observations. So in those days, I'm talking about 1910, 12, 15, 20, 30s. In those days, a peon from Bangladesh region can do these things. Nowadays, if somebody tells us or tells me that, okay, I am not understanding how to contribute, so that's why I don't have time, I cannot do this. That is not correct. If you are really interested to contribute in astronomy, nowadays, having the whole world, social media, internet, Wi-Fi, everything in hand, you can contribute. Definitely you can contribute. So basically, this is a motivating factor. That's why I'm showing this image to you. Now, apart from variable star, if you are interested not in variable stars, if you want to contribute in some other amateur astronomy or citizen science related astronomy projects, where do you get that? Go to this particular platform, www.zooniverse.org. Go to this platform. This is the largest platform in the world for citizen science projects in almost every subject you can see. Any subject you can choose, just drag on and go to space. You will see the total number of space related or astronomy related projects which are presently active. It will give a list. You can join any of these projects and you can start doing contribution. One such example I will show. So from this NASA, this Zooniverse, one such example is this one. This is a project known as Disk Detective, where if anyone is interested, you can join. If these projects will always not remain open, but if it is opening, in this particular project, what a person can do is you can join this project, you can learn about what is a disk, what is astronomical disk, and you can help in spotting disks around nearby stars, especially those stars which are forming planets. So basically in this particular mission, this particular project, NASA's one particular spacecraft known as WISE, it is an infrared spacecraft, having an infrared telescope. It is doing a whole sky survey in infrared and collecting data, collecting information about disks, dusty disks around young stars. Now, what astronomers like us, I am also a person in the area where I study stellar disks. So that's why I'm interested in this particular project, showing you all this particular project. So basically what we do, we study these disks and we try to say how the stars which are covered by that disk, how the star is, what are the nature of that star, whether it is forming a solar system or not, and how those stars behave, how stellar disks behave. By watching stellar disks, by studying stellar disks, we want to quantify and characterize the star's behavior. And in this type of project, we need your help, because who will detect, by watching those thousands of images, who will detect whether a disk exists in nearby a star or not? in that particular project, you can help. And definitely, if there is a good contribution coming from an amateur, there is recognition in the form of certificates, even from NASA or European Space Agency, whoever is launching this project. And at the highest form, one can also get acknowledgement in research papers. And in a very high form, one can also get co-authorship in research papers. I will show those things like this. From this same disk detective project, you see there is a paper there are so many papers, one of which is published in suppose 2020, before Corona, long-lived accretion disks around young M-type stars, published in a very well-known journal, Astrophysical Journal. And now you see the names of the authors. And specifically, I would like to highlight, see the names marked with the number 6, 6, 6, 6, and see who are they. 6 means disk detective citizen scientists. So these people are not professional astronomers. They are all basically amateur astronomers. You can count here the total number of authors in this paper. Out of these 1, 2, 3, 4, 5, 6. 6 of them are professionals, and 1, 2, 3, 4, 5, 6, 7, 8. 8 of them are basically amateurs. So it tells us how an amateur person, how anyone who is having an interest to learn, an interest to contribute, can actually contribute to some meaningful work in astronomy and astrophysics using citizen science projects. This I am showing from that same particular project, Disk Detective. If you want to check the list of all the projects, of all published papers, which has been published by using citizen science projects that has been designed by NASA, just go to this particular website and go on, scroll down and see all the publications. And see the number of people who have contributed, who are basically not professionals, but amateurs. So these are very motivating. So now let us come to India. Is there any citizen science project from India in astronomy? Yes, there are. Specifically, the first citizen science project for us developed in India was for astronomy. It still runs. This is known as RAD at Home India. RAD at Home means Radio Astronomy at Home. So basically, this particular project was developed by a Professor Anand Hota in 2013. This is one of the most successful radio astronomy projects, citizen science projects in the whole world at present. But for this particular project, you can join. You can go to this Facebook, their group. You can join here, you can learn and you can contribute. But for this particular project, since it is radio astronomy, you have to be a graduate student, either in graduation, either in engineering or maybe BSc courses. So being a school student, it is not possible for you to contribute in this project. However, there are other projects. So there is another project by classifying different types of galaxy features. And this project has been named as 1 million galaxies, developed by the help of IIA, Indian Institute of Astrophysics, and one Pune-based organization, Pune Knowledge Cluster. You can go to this particular website, and if you join this project, you will be able to classify the features of galaxies, and these galaxy images basically are taken by a telescope, which is 8.2 meter diameter telescope, Subaru telescope. So we need to classify galaxies. We need to understand what are the features present in a galaxy image. And we don't have that much amount of professional astronomers working in galaxies in the whole world. So that is keeping this in mind, this particular project was developed. There are certainly different other aspects, which I'm not going into details. So basically what I'm trying to give a glimpse is nowadays there are in India also and outside also, there are different types of citizen science astronomy projects, but anyone can contribute. Anyone, if you have computer access and if you are interested in astronomy, you can contribute. How to learn, what is this project about, everything is given here itself. Get started, and you need not have to read a separate book on galaxies to start this project. So every help is there. Still, if you want to do something more interesting, okay, I don't want to go to galaxies. I want to search asteroids. Is that possible? I want to search supernova. I want to search new exoplanets. Is that possible? that type of projects are also possible. So basically, we know that beyond our Earth, beyond our Mars planet, between Mars and Jupiter, there are so many rocky objects known as asteroids. And if we see this image, we will see that till 2003, this is till 2001, there are so many asteroids. All these red, blue, green dots are basically discovered asteroids. It is very important for humanity to discover and study asteroids, characterize them. Because you see this particular band, again, the picture will come. If you see this particular band, the third orbit is Earth's orbit. And you see there are some red color asteroids while revolving around Sun, they are crossing the path, the orbit of Earth. What will happen if they strike Earth? If an asteroid strikes Earth? It has happened many times in history. In our India also it has happened. If you go to this Maharashtra, there's a district called Buldana district. In this place, you will see there is a crater. Now it is a pond, this is an acidic lake. See this crater-like structure. This is basically known as Lonar. The place is Lonar, and this is Lonar crater. So we now understand that few lakh years ago, only a 10 or 12 feet small rock from space suddenly came and hit this place. What was the impact? It created a crater having a diameter of around 2 kilometers. Huge crater. The whole district was absolutely vaporized with the impact. Such type of asteroid hits, one such asteroid hit we know was responsible for changing the history of Earth. The dinosaurs. All the dinosaurs vanished away because an asteroid hit our Earth around 6.5 crore years ago. What will happen if any of these asteroids suddenly hits us? What will happen if an unknown, undiscovered asteroid hits us? This kind of cataclysm can take place definitely anytime. And that is why we need to study, we need to discover asteroids, we need to study them, we need to analyze them. Now, the discovery, the detection of asteroids, this is the place where students, public, and anybody can help. And that's why this particular project has been developed, International Astronomical Search Collaboration. Anyone can join in teams and you can search, you can do your work, you can ultimately help in searching of asteroids. So the first asteroid which was discovered, first asteroid discovered by Indian students, basically where in 2011, you can go to this particular news, 2 boys from Delhi Public School, Delhi. They were the first non-professional people from India or non-professional astronomers, astronomy people who discovered an asteroid. And who else can contribute? Can we contribute? Can a child, can an old person, whoever, can we contribute? You can contribute. How can you contribute? If you need any help, definitely I think that by this time, you know about that there is a group at present in WhatsApp. This is specifically a WhatsApp group of citizen scientists in India. This is at present India's largest citizen science group, specifically focusing on astronomy projects. It's known as SA Citizen Science Group. One can join this group by messaging here. The founder member of this group, Shubhan Acharya, he is also participating in this webinar. Today he is present. You can also talk to him, ask him questions if you want. So anyone can become a member of this group. And what will be the benefit? Basically, this group contains more than 3,000 volunteers across more than 300 members across India, almost encompassing all the states and UTs of India and across the world also. So basically, there are a huge number of groups who are actually helping anyone, any newcomer who is joining the group. If you want to contribute in citizen science, astronomy citizen science, how you can contribute, which project you want to join. So they are giving these group members, they are instructors, they are giving instructions and helping in more than 20 different astronomy projects which are running across the world. See, if you are facing some problem that, okay, I alone do not understand how to become a member and how to discover asteroids, you can join this group and gradually become a member of this group. There is no fees, nothing you require. You only require interest. And gradually you can become a friend of these group members and make a team, and instructors will be there to help you, to guide you. That if you want to go on with some good work, they will guide you. So this is how the group is helping presently extensively in spreading astronomy knowledge in India and obviously outside. What we have got? So this group was founded in around 2020-21, but within some days, these 4 or 5 years, we have seen that a huge number of students, specifically young students, coming up and trying to take, okay, I want to somehow contribute in astronomy. This is a Bengali newspaper cutting which tells that basically the youngest citizen scientist of NASA belongs from Calcutta, India, and this is the boy, Arush Noshkar. So at present, it was published in 2023. What he has done, he has helped in discovering 5 asteroid candidates. He was in class 5, 10-year-old, 9 to 10 years old when he did this. So age, gender, religion, status, nothing is a matter if you want to come forward and become a member of any citizen science group and contribute in citizen science. You can contribute. You see this girl, again a 9-year or 10-year-old girl, Vidisha Das, who has also helped in citizen science through this group. And ultimately, if even the contribution of any group member in any particular work is extremely good, suppose this work you see, this is a research paper published in a journal, MNRAS, Monthly Notices of the Royal Astronomical Society. It's one of the most famous astronomy journals, the oldest running astronomy journal in the world. So what they have done, they have actually basically discovered 999 exoplanet candidates. In this team, you see there are so many amateur astronomers, and you see the last name, the Shobhan Acharya from India. So if your contribution is really good, even you can get a paper which can definitely help your career. Definitely it will help you in your career if you want to go to astronomy physics or astrophysics in career. Now, let me try to come to the last 5 minutes to discuss how you can go to a career and why it is necessary, after so many years of studies of astronomy, again, why we should study astronomy. This slide tells you the answer. After so much of knowledge gained in astronomy for more than 400-500 years after the discovery of telescope, till now, we can only see 5% of the universe. The rest 95% is hidden from us. We don't know anything about that 95%. So somebody told correctly that now if your future will be bright if you want to study the dark universe. We doesn't know so many things about the universe till now. And that is why we need astronomers. That is why anyone who wants to become an astronomer, astrophysicist in future professionally, definitely you are welcome. If you want to go beyond amateur astronomy, definitely you are welcome. This is the right time, and the time is becoming more right because astronomy is increasing not only in our country, in different parts of the world. So to become an astronomer, what you have to do from an Indian perspective, I would like to highlight today. Maybe I will take another 5 minutes. See, we come from an institute. I am coming from an institute, Indian Institute of Astrophysics. What it does, it is a premium research institute of astronomy and astrophysics in India and also in the world, run by Department of Science and Technology, India government. It is basically an observational astronomy institute. So we have field stations. Basically, we have 4 premium observatories located across India, and we have some collaborative institutes or across the world. Definitely the best observatory, what I have told, is Kavalur Observatory, Vainu Bappu Observatory at Kavalur. We have a solar observatory at Kodaikanal, Tamil Nadu. Near Bangalore, in a place called Gourav Banerjee, we have a separate radio observatory. And another wonderful observatory, optical astronomy observatory, is present in Ladakh, Jammu and Kashmir, the northern part of India, northernmost part. So these are some of the facilities which we have. You can go to the details by looking at the IIA website. Yes, I have shown that I am talking to you people sitting somewhere here today. in this jungle. So this is the Vainu Bappu Observatory. The largest telescope of this observatory is having a diameter of 93 inches. So this diameter of the telescope mirror is 93 inches. This was Asia's largest telescope till 2010. Presently also Asia's largest 3 telescopes, optical telescopes, belong to India. So basically this is the 3rd largest now. So basically you see how big these telescope systems are. You see this telescope having all these instruments, sophisticated back-end instruments. It's a 6-storied building, and see people standing in front of the building. So these are the types of instruments and telescopes which we use for doing real astronomy research, because otherwise we will not be able to see the sky properly. If I go to Ladakh, if anyone travels from Delhi to Ladakh, the northernmost part of our country, Ladakh of Jammu and Kashmir region, you want to go to Delhi to Leh, you will cross this beautiful Himalayas in the morning, watching the sunrise at 35,000 feet altitude. And ultimately you will reach this Leh. This is Leh airport at Ladakh. And from this Leh, the town of Leh, if you go towards China border, nothing is there. Absolute cold, extreme cold. It's the 2nd coldest desert of the world. And its height is around 14 to 15,000 feet above sea level. Very less oxygen, but wonderful place. As you go 250 kilometers away, very near to this China border, we come to a place known as Hanle. So this is a small, very small village kind of place, Hanle, where we have our Indian Astronomical Observatory, IIA. So as I have told that India is having world-class research institutes and observatories spread across India, and obviously we have collaborations across the world. Not only IIA, all other institutes of India also. So this is the right time. If you want to take astronomy, you can, definitely you can come to this field. Apart from, as I have told, apart from IIA, you go to Nainital, Uttarakhand, you see a whole hill taken by government of India for creating wonderful institute, come observatory, known as ARIES, Aryabhatta Research Institute of Observation and Sciences. Going back to different places, you see as I was telling, Asia's largest telescope at present is under ARIES in a place near to Nainital, 60 kilometers away. And this is the telescope dome. 3.6 meters is the diameter. So we have these things. We also have the world's largest, basically the world's largest liquid mirror telescope, absolutely used for astronomy. This is a liquid mirror telescope. I'm not going to details, just giving a modern aspect to you that if you want to come to astronomy studies, presently we have different top class research institutes focused on astronomy and astrophysics. For example, IIA is there, IUCA, Inter-University Center for Astronomy and Astrophysics from Pune. This is S.N. Bose National Center for Basic Sciences from Calcutta, ARIES. Obviously, we have National Center for Radio Astrophysics, Pune. This is again a famous building, IISc, Indian Institute of Science, Bangalore. And we also have a separate university in whole of Asia. This is the only university absolutely on space science studies. This is IIST, Indian Institute of Space Science and Technology. And this is under ISRO. So I'm just in one page showing a glimpse. There are lots of wonderful research institutes, IITs, NITs, ISRs, and different universities. Every year, different universities coming up with astronomy and astrophysics hardcore courses. If you definitely take part or take any of that courses, you can join professional astronomy. What to do for that? See, whoever you are, if you officially, professionally want to become an astronomer, or basically not an astronomer, I believe that if you want to become a researcher, professional researcher, maybe in any field, these 3 qualities you need to have. Passion for the subject, patience. For years you will go on working on one object, you will not get anything. One day suddenly you will get all the results. Now that patience is extremely important. If you leave your work in the middle, then somebody else will take the fruit. And punctuality. You cannot wait. You cannot say that, okay, I will do my work tomorrow. Tomorrow ultimately never comes. So if you want to become a professional astronomer, a professional researcher, if you do not have these three qualities, I am sorry to say, don't become a researcher. If you have this, if you believe that if you have these three things, definitely try to gain knowledge in astronomy as early as possible, maybe from your school days. Read books, use internet and social media wisely. Right. See documentaries, read internet-related resources, try to see which are authentic, which are not. Visit nearby science centers, museums, planetariums, attend these type of workshops, schools, courses, whatever is possible for you. And basically, what is your goal? To try to start developing fundamental knowledge about astronomy and trying to understand which information is authentic, which is not. This will help you as you grow. And one aspect definitely which will help in these things is gaining astronomy knowledge. You can join some amateur astronomy organization. Nowadays, I believe in almost every city of India, nearby, even small cities, nowadays some amateur astronomy organization will be there. Try to join those organizations. You will gradually learn about what is sky watching, what is telescope handling, basics of astronomy. You can participate in their seminars, in their astronomy camps. So basically, this will give you knowledge, gain knowledge about astronomy. It will also help you to gain some other types of qualities, like, working in groups, adapting in different extreme environments, whether you can manage yourself in extreme places, management skills. So these things do not come by reading books. If you join camps, if you join workshops, if you join seminars, if you're traveling to different places for astronomy camps, you will automatically start learning about these things, that how I should work in a group, how I should stay in a tent with 3 other people without quarreling. These things are very important for anybody who wants to become a good researcher. This is the Jyotirvidya Parisamstha, India's oldest amateur astronomy association, based in Pune, running from 1944. So that's why I'm showing its picture. But apart from JVP, there are so many other organizations almost in every city and every town of India. Search it from internet and join. Try to join, try to track with them. Now, professionally, after 10th level, what you will study, definitely you have to study pure science. Definitely physics and mathematics should be a subject. You should have very good knowledge as much as possible, very good knowledge about physics and mathematics. And nowadays, at least one computer programming language, you should have knowledge. Without computer programming, astronomy research is not possible. Also, at the same time, as you are doing your learning, you are going to camps, you are attending conferences, workshops, talking, discussing with people, you see, you will gradually becoming fluent in English. You will gradually gain these skills, listening skill, writing skill, reading skill. These are important. But officially, you have to take pure science. This is one major way by which you can come to astrophysics. And after 12th standard, either you can go to, obviously, physics, graduation with physics major, or you can go to BTech. It's BTech in electronics, computer science. So basically, if you in future want to develop space technology, if you want to become a space engineer, if you want to become an astronomer who develops astronomical instruments for astronomers, so then you have to go to BTech. And if you want to study stars, galaxies, their properties, you have to go through physics. And after you gain graduation in physics, do masters. Masters in either physics or masters directly in astronomy and astrophysics. So presently, there are some very wonderful places, great places, universities in India who are offering masters in astronomy, astrophysics. 4 such universities are these: IIT Indore, IIST Trivandrum, Osmania University, this is in Hyderabad, and Presidency University, Kolkata. So these are some universities, prominent universities, which offer MSc directly in astronomy, astrophysics. And there are, you see, I have written what type of exams you have to give. You have to read through internet, search through internet, what are their eligibility criteria, how to go to those places. You yourself do a search, do the homework. Now, ultimately, if you want to become an astronomer, when we call a person as an astronomer, if you have PhD in astronomy and astrophysics, there is no other way we can call a person as an astronomer. So for doing PhD, basically doctor of philosophy, you have to understand astronomy, astrophysics is an academic line. So here, if you want to get a good job, minimum you have to have PhD in astronomy. And for getting PhD in astronomy and astrophysics, PhD is offered by basically top institutes of India, science institutes or astronomy research institutes, or some very top level universities of India. If you want to take admission there in PhD astronomy, you have to give any one of these tests, either JEST or NET or GATE. So basically, I would like to end by showing what it means actually. If you go to JEST, this is a very special exam, joint entrance screening test. If you give this JEST exam, through giving JEST exam, you can basically join PhD in astronomy, astrophysics in any of these institutes. Just go to these participating institutes, click here, go down. You will see everything is written, which are the institutes which take PhD through JEST exam, and what are the subjects which are offered there. So out of these institutes, how many are offering astronomy and astrophysics? Everything is written here. You can just click any of this institute name, just click here and then enter the institute's website, Indian Institute of Astrophysics. And if you are going through BTech, if you want to become an astronomical instrumentation person, so IIA and ARIES both have a unique opportunity for those people. Come to these opportunities, come to this MTech PhD program. You see, this is offered by integrated MTech PhD in astronomical instrumentation. This is offered in India only by two renowned institutes. One is IIA, one is ARIES. What are the eligibility criteria? Everything is given here. You just click here. You see this. For integrated MTech PhD, this is the qualifying degree and the eligibility for sitting in the interview. And if you clear the interview, you will get the chance. If you want to not do in MTech PhD, if you want to do PhD in astrophysics at IIA, this is the eligibility criteria. So likewise, you can go to this particular website, click on participating institutes and see all the institutes, make a list who are actually offering astronomy, astrophysics. If you do this homework properly, it will be very helpful for you when you are actually coming to that stage that I am giving JEST exam. Now I want to select where to go, how to go. This will help you if you do your homework, maybe from today onwards. So I would not like to extend my talk very highly more. I feel that I have been able to give a very basic glimpse that how you can ultimately join astronomy and astrophysics. And yes, there are also certain basic top class private universities like Christ University, Bangalore, where I belong from. They also offer astronomy and astrophysics nowadays. And any one of you, if you want to wish, you can also read this book, Becoming an Astronomer, written by me, where whatever I have written or told about how to become an astronomer, that is all written in this book. It's a guidebook for becoming an astronomer, mainly from Indian perspective. Well, thank you everyone. If you have any question, if you want to ask anything, the stage is open for you all. Thank you everyone.
Thank you so much, sir. Thank you so much. This was an absolute feast to watch. We'll now take questions. People who have questions may raise their hands and we'll pick and choose from people. You'll have to open your mic and your camera. Till then, we'll take questions from the chat. I'll read them out to you, sir. And Huda V asks, sir, I have a very modest experience in heliophysics. I was curious to know how we can specialize in one particular field, that is after exploring all that this field has to offer. I mean, how can we go about finding that one niche topic that appeals to us in a whole of astronomy?
Okay. Let me myself open the chat box. Yeah. Okay.
It's towards the top.
So you have to do, okay, which question? Huda, right?
Yes.
Okay, sir, I have a very modest experience in heliophysics. I was curious to know how we can experiment one particular field, that is after exploring all that this field has to offer. Okay, I mean, how can we go about finding that one niche topic that appeals to us in the whole of astronomy? Yeah. Huda, yeah. So this is a wonderful question. But first of all, you see, basically, if I say that if you already have some idea about heliophysics in solar physics, so basically, see, it's the astronomy and astrophysics, these are so huge topics or area, even learning everything about this field and then exploring, it is not possible. Till now, we know only around 60% of what sun is. We have no idea about the rest 40%. In solar physics also, so many unknowns remain. So many things are unknown to us in solar also. So basically, when you are in-depth studying or you are in an in-depth, you are going to a master's project in solar physics with some proper professor or postdoc and doing some particular research work, then you will be able to gain what are those unknowns, which particular unknown phenomena or which particular unsolved mystery exists in solar physics. So if you do a master's project or a graduation project or a pre-PhD project, before joining PhD, you are doing a project, research project, then you will understand. And that time you can gradually narrow down, okay, whether I am interested in doing further works in that particular area, solar physics or some other area. So this is how gradually you can narrow down. This is what we generally follow. We tell our students, okay, suppose the type of work which I do in stellar spectroscopy, naturally a student who is under me will have to do some work in stellar spectroscopy. But what are the unknowns? So anything which is unknown, we can handle it. So that student will be a part of that ongoing project. Now we will be able to, that student himself or herself will be able to understand as the project is going on, whether he or she wants to continue. If that is the case, then we definitely tell them, okay, please go for the exams, take some national level exams or international level and join PhD in a right place. So this is how you can narrow down. But suddenly if I read about suppose astrobiology, I might not understand what are the important aspects of astrobiology where people are working now. And so it's always good after citizen science, in a professional way, if you go to a hardcore research project, as a project intern, if you join in any good institute in India or abroad, that will be the way by which you can narrow down your interest.
Thank you, sir. Atufa asks, I am really interested in cosmology. As someone passionate about cosmology, how can I properly explore and understand its essence to truly grasp the nature of the universe?
So Atufa, if you are interested in cosmology, first of all, as I have told, for gaining knowledge and becoming more interested in any subject, specifically in a fascinating subject like astronomy, astrophysics, you have to read books. There is no other way. You can also read the same thing from internet, but this is a bit difficult because you might not know which are the things which are written authentic, which is not authentic, because there are so many things which are written by many people. So, but you have to read some good books and basically not textbooks. I suggest first start with some very good authentic popular science books, popular cosmology books. There exists some such books. Definitely there exists. So if any one of you want, maybe I can send a list of some good books in astronomy, popular astronomy books in different fields, including as cosmology. I can send a list of such books, which you can buy from Amazon or somewhere. And try reading. As you go on reading and reading and reading, you will become more and more interested. And then ultimately you can go to professional way. Definitely you can also contribute in an amateur way, but in a professional way, if you want to go, the best friend of yours can be your parents and books. There can be no other best friend. And so that you have to follow. Okay.
So Akash goes on to say, sir, many young minds dream of exploring the universe, but often don't know where to begin. What's your message to students who wish to turn their love for stargazing into a real journey in astronomy?
I guess I have discussed this aspect only, right? Yeah. So your career path, how you can focus on. So if you, I guess this is recorded. So if you again see the YouTube version, the career means how to develop passion, how to read, how to become a member of an amateur astronomy organization, start contributing in citizen science, maybe 5-6 projects you are doing, graduate, and read. The best part is reading. If you don't read, then there is no royal road to knowledge. As Newton told, there is no royal road to mathematics. I changed that version and tell there is no royal road to knowledge. Nothing will come to you free of cost, means basically free of hard work. So you have read this Mahabharata, right?
Yeah.
When Yudhishthir was told that, okay, if you want to take this much land, you have to fight and earn it, achieve it. This much land. So basically, it's true. You have to read and then only you can understand. But yes, try to follow this type of, in this talk also, try to follow different talks, attend different seminars, and you will gain an understanding and read astronomy books, gain knowledge, and try to use internet in a wise way. Search list of Indian universities which offers astronomy and astrophysics. Nowadays it will come. Yeah. So likewise, list of good astronomy books in India, present in India, present in Amazon. You will see crores of books. Take the first book and read. This is the thing. So gain knowledge. That will help you, definitely.
Another one of the questions, Nawaz Khan. I completed diploma in electronics communication engineering. I can build my career in communication field. I want your guide.
Yeah, I mean, see, communication field, if you want to make your, means I am not the right person to guide there, but if you want to come to astronomy and astrophysics and become an astronomical instrumentation expert, then definitely I have shown there are paths. After BTech, you can join integrated MTech PhD. Obviously, you can also apply outside, means through exams and you can apply outside for astronomical instrumentation, which will lead to developing astronomical instruments related to communication, telemetry tracking, softwares, all these things. But if you are thinking about absolutely communication field, I'm not a part of that area, so I will not be the right person to answer this. Yeah. So yes, if you want to come to astronomical part, that definitely you can. You can definitely come, as I have mentioned. Yeah.
Yuvraj says, for bachelors of physics students, what should they focus on in terms of skills and CGPA to go through ahead in astrophysics, astronomy, or cosmology?
Yeah, Yuvraj, this is good. Okay, let me show you. I guess it is there. You see, I have shown this image, right? Okay, let me share the screen. Suppose you want to take astronomy and astrophysics professionally, you want to join PhD in astronomy and astrophysics at IIA or at any such top-level research institutes. You see here, as I have shown you, go to IIA website, go to their opportunities, come to graduate school PhD program, you will see, and go to their qualification or criteria. You see a minimum of 60% throughout the academic career. Post-graduation degree should be from a UGC recognized college or university. And everything is written. Applicants should have a valid CSIR net score in physics at the time of admission or GATE score above 95 percentile or JEST score above 95 percentile. This should be the age limit. Everything is written here. Everything is already in the internet. Just go to those places and search it. So if you want to see, as I have told, JEST, see, go to JEST, click here, participating institutes. These are the premium institutes of India. How many of them are offering astronomy and astrophysics is written here. Suppose Aries, go to Aries and search it. You do the homework yourself. Yeah, you search it, you do the homework yourself. That will be beneficial for you. Because otherwise, how will you know? Everything is there in the internet. So here might be my internet is not that fast, but you go to Aries and you can search it out. Yeah. Or you go to any other institute. Suppose you see, if you are interested in theoretical astrophysics, HRI, it is at Allahabad. You go to HRI website to see MSc program in physics, PhD program in physics. You click here. Okay, doctoral physics, curriculum and detailed course content, course structure, everything is given. Whatever you want, you can get. Yes. So basically, this way you can go on searching. The Aries, see, this is Aries, opportunities. So this is, you see, PhD program. And so it might be a bit slow from Aries point of view also. So you can search like this. You just search and make a homework, do your own homework. You make a proper homework. Every one of you who want to come to this professional astronomy field, do a homework before coming and suddenly jumping. And because in the interview, they generally ask, why do you want to join IIA? If you tell that I suddenly one day heard a talk of Gourav Banerjee sir, who is from IIA, so I want to come, then you might not get selected. You might be very good in mathematics, you might be very good, having very good marks. But that type of answer you should not give. You should have a valid answer. Okay, I'm interested in astronomy. Why? Why IIA? Why not NCRA? Why not ARIES? Yeah, so that way it should be your own homework. Give some time for that. And a pre-preparation, what is called. This is what many people call as luck factor or X factor. But basically, war is not won by luck. It is won by technique and preparation. Proper technique and preparation. Luck might play 1% in your life, maybe. But many people who will fail to clear these entrances might say that, okay, my luck was not good. But basically what was not good, my X factor is not good. But basically what was not good was not X factor and luck. Pre-preparation and technique for the war. So if you are good in that, you can crack the best places of the world also. You need not have to be Einstein, Newton for that. Nobody. Einstein, Newton, these are all exceptions. And so just go on. If you are interested, just apart from taking photographs of sun and moon and stars, give some proper time in doing a homework about what are the opportunities available in Indian astronomy. Which are the institutes offering Indian astronomy? Because I have already shown you, you see, I have already shown you, go to this place and read about it. Make a note. See, where do I want to go? If I want to go to theoretical astrophysics, which is the best place? So if you want to go to solar astronomy, and if you go into an institute where solar astronomy is not there, then you will not get a chance. These things you do a proper homework. All these things. Yeah, so I guess somebody has raised hand. Atharva.
Yeah, I'll pick them out. Atharva, you may let me switch out the settings so that everybody can open the mic. Atharva, you can now open your mic and you may ask a question.
Yeah, Atharva. Yeah. Hello. Yeah. Yes, Atharva, you're audible. Yeah.
So first of all, thank you, sir, for this great session.
Thank you.
Sir, I want a simple career advice from you. Sir, I am currently doing my bachelor's in technology in CSE. Also, sir, I will be doing my master's in technology from IISc. I'm actually targeting it.
Okay, that's good.
After that, sir, I will be working as an ISRO scientist or any other place. So simply, sir, I want to just know from you, how can I, sir, learn astronomy?
Your CSE knowledge, right? Your computer science. Yeah, definitely.
Yes.
Computer science, you are doing BTech means, don't worry. You just focus on gaining computer science knowledge, specifically programming. Computer science is in every aspect of astronomy research, computer science is necessary. So basically, if you want to design a spacecraft, any instrumentation, any software, see, we're using huge softwares. Data retrieval, data reduction, then data analysis, all are done using the help of softwares and instrumentation. So for instrumentation, this instrumentation, electronics, electrical people, civil people, they are helping in developing the instruments. CSC people are helping in developing the softwares through which we can gain the data, we can ultimately reduce the data, analyze the data. So basically, if you are going to IISc or some top institutes for your master's, then PhD, definitely you can take PhD in astronomy and astrophysics by going through GEST and all these things. So prepare for, apart from your BTech CSC or MTech CSC, prepare for the GEST exam or NET exam if you want to stay in India. So if you're
actually, sir, my family is not allowing me to do PhD or like go above, as they know that keep job kar lo bas.
See, in astronomy, if you want to take a job, definitely fantastic jobs will come, but after PhD postdoc.
Yes.
After MSc is nothing. After MSc, if you want to do job, you have to go to some IT sector, some computer science BTech or MTech jobs. As IT sector, mainly computer science people will have opportunities in IT sector, banks and other places where computer is there. But astronomy, if you want to come, there is only one way. You have to become an astronomer. And that is a long, hard way. But after that hard path, will gain the life of a king or a queen. But that you have to understand. If your family is agreeing with it, if your financial condition supports you, then definitely you can go for it. Otherwise, you have to think, you see, by doing MTech in computer science, that is not astronomy. So by doing MTech in computer science, you cannot get a job in astronomy, but you will get a job in computer science, definitely. That you have to very well decide. Talk with your parents, because doing PhD postdoc in astronomy, astrophysics, it will take at least up to the age of 34, 35. After that, you will get good job, definitely.
So, like currently, sir, I am reading some books also of astronomy. Also doing, sir, there is a club in my university, the Astro Club. They are also supporting me, like they are in some events like stargazing and all. Currently, sir, my senior is saying that he will give me a research topic on TDS boot law. Also, sir, I'm just reading about it, like many research papers, I am just searching for it. I'm doing some here time like research here. So, sir, I would just want to somehow contribute in astronomy and research papers. So, can I as a non-professional astronomer also?
You can contribute as a non-professional astronomer, but job is not there.
Yes, yes.
Yeah. I mean, as I was telling, you see, if you're an amateur astronomer, definitely you can contribute. Whole life you can contribute if you're interested in astronomy. Even you can meaningfully contribute in future, definitely. But if you want to become a professional astronomer and become a professional astronomer in an institute, in a top-level institute like IIA, IUCAA, or an university faculty, ultimately, if you want to require a job as an astronomer and identity as an astronomer, then you have to become an astronomer. There is no other. So this is same in India and abroad also. So basically, it's the same thing. See, if I want to do surgery, I like that. If I don't become doctor and then also masters in surgery, then I'm not allowed to permit to do surgery. I might like it, but I will not be permitted to do that. This is the same thing here.
Sir, I can also contribute as non-professionally.
Yeah, you can contribute. As I was telling, maybe half of my talk was on that only, the citizen science contribution. You can do that. Definitely you can do. There is no harm in it. Definitely, yes. Yeah. Thank you. Yeah.
Thank you, sir. I think we'll take Yashwant's question. Yashwant, you may go ahead.
Yeah.
Hello, sir. I'm Yashwant.
Hello. Hi.
I'm actually a high schooler. Sir, I want to know from you that how an ideal career path for astronomy should be like.
Ideal should be, see, if you are going, as I have already told, if you are going through pure science, then it should be following through physics. So graduation should be in physics with fantastic marks and everything. As good as you do, because see, astronomy and astrophysics, quantum physics, these are some subjects which are very tediously difficult subjects. For me, it is very fascinating, but for many it is fascinating. But if you want to go deeper into it, actually it is difficult. Actually, it is one of the most difficult subjects in the world. Astronomy, medical science, quantum physics, because you cannot see what you are studying. You cannot bring the star to your laboratory, cut it and see what is going on inside. You only get very faint radiation coming from that, which you have to study and infer what is going on. So basically, studying astronomy, quantum physics, if you want to do, you have to have a very good knowledge about, in-depth knowledge about physics and mathematics. And nowadays, obviously, computer science. So either you can go through this path, follow physics with your wonderful marks and everything is necessary to get, because astronomy, astrophysics will be offered by mostly top-class research institutes or universities across India and abroad. So any normal institute will not offer you PhD in astronomy. So for gaining a position at a top-class institute, that's why these things come. 95 percentile marks, then interview, then very tough interview. All these things you have to go forward with hard work. And if you cross these things, definitely you can come. And if you want to go through engineering, then you can take engineering in computer science, electronics, electrical, mechanical, even instrumentation, and ultimately come to the astronomical instrumentation part. So you will be an astronomer who will be developing the telescopes, the facilities through which we do our observations. So these are the two ways, basically. As you grow up, as I am telling to many of others also, try to start reading about astronomy, books. How you read the books is up to you, whether you download the PDF or you buy it or you somehow resource it from library or internet. That is up to you. Read. As you read and read and read about a subject, you will gain an overall understanding what is happening in the world, what is happening in India, what type of works are going on. Suppose you are interested in galaxies. What type of things are unknown about galaxies? What are the some unsolved questions about galaxies? So how will you get this knowledge? By reading only. So this way, since you are in high school, I guess you are in class 9. So now you go on. Is this the right time? You are in right time. If you start developing your knowledge, then when you go to PhD, that time you will already know that, okay, I know what is a galaxy, what is a star, how planets form. I know the basics of astronomy. I know how basic astronomy works. That will be helpful for you, definitely. So either you take physics, if you go through pure physics line, or you take engineering and for going to developing the astronomical instruments for astronomers, like telescopes, cameras, spacecrafts, like that. So this is
Sir, in my case, I am like deeply interested in physics also. Like basically, I am like working on a review research paper on topic of space weather.
Okay, that you can go definitely. Yeah.
And like, do you think are there any other things which I can use to improve my knowledge and other things?
Read. Definitely, there are lots of things. Read about astronomy. Read about space science. Read about space weather. And read. Suppose you see sun. Can you tell me 5 things which we don't know about sun? Yeah.
Like by only seeing it.
Yeah. Can you tell me one aspect which happens in the world, which we suspect that it is related to space weather?
Right.
It is a very rare thing, which happens only in India. It's about a flower. Every 12 years. And there is a faint suspicion, this is known as Kurinji flower, which blooms in very few parts of Nilgiri forests in South India, Nilgiri Pajani hills, every 12 years once. And the amount of this flower blooming, the rate of flower blooming, somehow we suspect that it is related to solar cycle. It increases and decreases with solar cycle. But we don't know how it is happening. And if it is proved, this will be the first proof that space weather directly affects life. Space weather affects Earth's climate, that we know. So this is the thing. So see, suppose if you are going to an interview and you say that I have done some work on research on space weather. And if the person asks, okay, can you say something about space weather? 5 minutes. Can you tell me something about space weather? I don't know space weather, but why I should study space weather? Can you tell me? 5 minutes talk. What will you tell? You will tell about what I have done. No. What impressive thing, what magical words you will tell that person will think, okay, this person I have to take.
Like facts and other interesting topics, what is the reason of studying space weather?
How will you gain these things? By knowledge. Knowledge is the ultimate supreme power. There is nothing above knowledge. So gain knowledge. Gain knowledge as much as possible. Try to start gaining knowledge by reading books, by through internet, by your research, by reading papers, whatever possible. By going to libraries, your school library, whatever possible. Just go on reading. You will see the best, the world's most renowned, the greatest people of our world. They have all been very knowledgeable, extremely knowledgeable. All the greatest people of our world, irrespective of nation, religion, caste, region, they were basically, think about Abdul Kalam. He is a person who knew about missiles. He is a person who knew about physics. He is a person who knew about chemistry. He is a person who knew about spacecraft technology during the time when nobody knew about spacecrafts, how to develop a spacecraft in India. He's a person who was a policymaker, who knew about politics, who knew about how to take funding, who taught him? Himself. This is the thing. Yes.
And sir, in your session, I observed you mentioned about coding.
Hmm.
Like I'm basically with help of AI, I developed an